We're going to kind of just go through the idea of each kind of factoring. In my opinion, the hardest part is looking at and figuring out what to do. How do you know what kind of factoring to do, what steps to take? And so I try to organize it in a way in which I think is a good approach. The first thing you want to ask yourself every single time is, can you factor something out? Because sometimes you can factor something out and do something else, but it's always easier for you if you can factor something out. So in something like that first example, you're looking to see if there's something that you can take out of both terms. If there was 7 terms there, you would want to see if there's something you could take out of all 7 terms. And you want to look at the coefficients or the numbers on the front and also each variable. So if I look at just the coefficients, for example. So if I look at the 3 and the 15, is there a number that goes into both of those? 3, right? So I'm going to take out a 3 from both of them. And then, is there a variable that I can take out of both of them? X, and the highest exponent I have, I want the smallest exponent I have on X, which is to the first. They both contain 1X, at least. And then I go to the Y, and what's the lowest exponent on the Y? Y squared. So what I'm going to do is basically take each of these terms and divide it by what we're factoring out. Okay, so again, the better you get at this, the easier this will be, and the more of this you can do in your head. But for now, we're just going to kind of baby step our way through it. So the 3's would cancel. If there's 2 X's and 1 X in the bottom, that would be 1 X left, and then both the Y's would cancel. Plus 15 divided by 3 is 5. The X would cancel, and 2 of the Y's would cancel. And my answer would be left like that. Hang on. Because you're factoring it out, but it's still part of it, right? You can't get rid of it. You're not dividing by it. You're just rewriting the same expression in a different format. So every single problem that you get that is factoring, if I took my answer and I multiplied it back out, I get my question. We're not reducing these in any way. We're just rewriting them in a different way. So if I were to distribute this back in, right, I should get my answer. 3x times x is x squared, y squared, plus 3 times 5 is 15, x, y squared, and y squared would be y to the 4th. So every factoring question can be checked. Questions on factoring out the greatest common factor? where I would say next approach is figure out how many terms there are and let that drive what happens after. If there's 2 terms, then there's 2 questions, okay? One is, are they perfect squares with a minus between them? And the other is, are they perfect cubes? What's a perfect cube?
To the 3rd power.
Good. The result of something being raised to the 3rd power. Everybody understand that? So if I had 16, is that a perfect square or a perfect cube?
Square.
It's a perfect square. Everybody understand that? How about 64, perfect square or perfect cube?
Cube.
Trick question.
Square.
It's both.
Oh.
It is 8, right? It is 8 squared, but it is 4 cubed. So then you would have to look at the other term and see, is the other term a perfect square or perfect cube? It's going to be one of them.
Is it possible for you to get both with both numbers?
No, like either your first term or your second term, one of them would if one of them is both, then the other one would have to be different. It would have to be a square. Unless you can take something out, which always goes back to that first term. Because from 64, I might have been able to take 4 out of it. And now I'm at 16. Now it's a perfect square. Okay, so you always want to go back to the first thing. All right, so if it's 2 terms, and both terms are perfect squares, and there's a minus between. So it does not work if there's a plus between them. Okay, if it's a minus between, these are called the difference of 2 squares. So the terminology there is the difference of 2 squares. Difference means what? Minus and 2 squares, right? We're looking at the difference of 2 perfect squares. If that's the case, then you square root the first term, you square root the last term, put them in the parentheses and duplicate it so that you have 2 of the exact same things, and one gets a plus and one gets a minus. So if I look at 4x squared minus 25, can we agree that these are both perfect squares? 4x squared is a perfect square, right? And 25 is a perfect square. And can we agree that there's a minus between them? Yes. So I would square root the first term. So the square root of 4x squared is what? 2x. What's the square root of the second term or the last term? 5. I'm going to duplicate this. 1 gets a plus and 1 gets a minus. The order there doesn't matter. It could be 2x minus 5 and 2x plus 5 as long as 1 gets a plus and 1 gets a minus.
If it's a plus sign,
Then it's prime. Then you can't even factor it.
Why?
Because there's no such thing as the sum of two perfect squares. So watch what happens. So if I were to FOIL this back, this is my answer, right? If I FOIL this back out, so I multiply first, that would be 4x squared. Outer, negative 10x. Okay, then I'm on inner, positive 10x. Outer, negative 25. And then these cancel, and I get 4x squared minus 25. So if we had like accidentally looked at a plus model and said that, okay, this is x plus 5 and 2x plus 5, or if there are minuses in between, that middle term won't cancel out. So there's no way to get two terms, right? This would combine to give me 3 terms. There's no way to get 2 terms if they are not opposite signs. We need them to cancel each other out. Does that make sense? So if it had said plus here, if this was a plus, that would actually be prime. Prime means you can't factor it. Okay? It doesn't mean it's wrong. It just means it's not factorable. So different to 2 squares has to be a minus. Good so far? Yeah? Okay, the other case, if it's 2, is if they're perfect cubes. So we said common ones are like, obviously 1 cubed is 1. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 is 125. It's probably about as high as you would get quizzed or test on, but you can keep going. You would just, if you didn't know something, you'd have to break it down using a factor tree to see if it's a perfect cube. So this case can have a plus or a minus in between because you'll find the pattern works either way. But how we break it down is by following this little model. So what I do is I look here, and I say, okay, both 8x to the third and 27 are perfect cubes. And the sign in between them is what? A minus. So I'm going to follow this second pattern. So the first thing I have to do is identify a. So I have to cube root 8x to the third. What's the cube root of 8? 2. What's the cube root of x to the third? X. That's my a term. Then I have to cube root 27, which would be what? 3. So this is my A, and this is my B. So when I follow the pattern that remains, I'm going to plug those values in. So I would get 2x minus 3 times A squared, so 2x times 2x, or 4x squared, plus the product of these, so 2x times 3, 6x, plus B squared, 3 squared, which is 9. God bless you.
Thank you.
So the only thing that would have changed if it was a plus would have been the first sign and the second sign. Now if I FOIL that back out, if I take and distribute 2x to all 3 terms and then negative 3 to all 3 terms and combine my like terms, I end up back with 8x to the third minus 27. Mm-hmm.
So what is that called?
That's perfect cubes. So sum or difference of perfect cubes, because it could be both.
So it's like, would you get a question?
You could see something that says 8x to the third minus 27, it'll say factor. And you've got to identify that those are perfect cubes.
And then that's the answer. Yeah.
And then this would be your answer, this whole thing here. That would have been your answer. Questions so far? You want to practice one of those? Okay, so somebody said nope, sorry. The rest of you got ruled out. All right, so if 125a to the third is my first term, what is that cube rooted? 5a. And b to the third cube rooted would be b. So the first set of parentheses, I keep the sign 5a plus b. What's the first term in the second parentheses? 25a squared. So I take that first term and I square it. Then do I use the same sign or I switch the sign in that? Switch it. So if it's a plus to begin with, it becomes a minus. And I multiply the two together. So 5ab. And then the last term, b squared. And it's always positive because we're squaring something. So it will always be positive. Whether that term was positive or negative, it will always be positive. No. So the a and the b, when you're identifying the a and the b, you cube root each of those terms.
Oh, okay.
Yep. So the pattern when you're expanding it is to keep the first parentheses gets the same sign as your original. Then the next sign would be the opposite, and the last sign is always positive. So first stays the same. So if my initial problem was a minus, then it's a minus plus plus. If it's a plus, then it's a plus minus plus. So the first one's the same, second one's the opposite, last one is positive. And again, like we could walk through this by foiling that out, expanding it, and showing you that you would get back your question, okay? Questions on that one? Okay. All right, so then the next one is, so that those two options are if they're two terms. If none of that applied, then my polynomial would be prime and I couldn't factor it, okay? If there's four terms, then you're going to factor by grouping, okay? That's what this is called. So when you factor by grouping, you group together the terms in pairs. So if you look at the one that I've got there in purple, if I were to group together these terms in pairs, I would put parentheses around each pair. And then I would factor out the greatest common factor from each pair. So I'm going to look at that first set of parentheses, and I'm going to ask myself, what can I take out of there? They both have an m. Good. So the m goes on the front, and then I'd get p squared plus 7m. With me so far? Because I made a mistake. I was just making sure you pay attention. That would be p squared plus 7. Now I do the same thing with the second set of parentheses. So that 3p squared plus 21, what can I take out of there? 3. So a 3 goes on the front, and I get p squared plus 7. Now, if I've done it correctly, then what's inside of the parentheses should match. So this looks like this, right? That now becomes my greatest common factor. So I take that out. So what I'm doing is taking this whole term and dividing it by 7p, or p squared plus 7. This whole term, dividing it by p squared plus 7. This is going to be gone, and this is going to be gone, and what's left gets grouped together. So m plus 3 gets grouped together. So once you identify that the parentheses are the same, right, you're taking them out. So by taking them out, I put that on the front, just like we did with the greatest common factor, right? I took that greatest common factor, put it on the front, and once I've divided both those terms by it, which it will cancel out, and whatever's left over, so whatever term was attached to it, is going to get grouped together in the second set of parentheses.
And you, if it was can it be negative?
Yeah, so if it was negative 3, it would have been m minus 3. Yep.
But why'd you rewrite the p2 plus 7? Because it's the GCF? Or?
Because it's greatest common factor. So again, we're rewriting it, we're not dividing it, right? We're not changing the value here at all. We're just writing it a different way.
Okay.
So if that was a negative, so Chris asked about the negative, which is a good question. mp squared plus 7m minus 3p squared minus 21. So let's look at it this way. Now when I had grouped the initial ones together, if I had put the parentheses, so if I had put the parentheses here or here, does it change the value of that 3p? A plus is not going to change anything, right? But if it's a minus, it does change it. So if there's a minus there, you need to keep the minus with the number, because that negative applies to the 3 and not to both. So I would still take out the same term. I would still take an m from the front, and I'd get p squared plus 7. Now let's say I took the same thing out. Let's say I took out a positive 3. I'd end up with negative p squared minus 7. Are the parentheses the same? No, but they are opposites, right? So if I change that 3 to a negative 3 instead, and I take out a negative 3, now my signs are the same. You with me? So pay attention to the signs. What's in the parentheses has to be exactly the same. So then it would be p squared plus 7 times m minus 3.
Usually, like, whatever the sign is, it just always is on that side, pretty much.
Usually if it's negative, it's going to get taken out, but not necessarily all the time. Like if that first term was negative mp squared plus 7m, and then it was negative 3p squared plus 21, now the negative would stay inside the parentheses. Questions so far? Okay, sometimes you have to regroup in order for it to make sense too. So let's say, okay, so we're going to try it, everyone. All right, so when I first look here, right, I might need to rearrange this. This one can actually be done either way, but let me show you what it looks like if you have to rearrange it. So if I have to group together, there's some that just have A's, so if I were to group those together. And then there's ones that have B's. So sometimes you can group them together more than one way. 4A. Oh, 4A isn't squared here. This one. Yeah. Okay. Once I get it in here, then I can group it like we did before. From that first set of parentheses, what can I take out? 2A. From that second set of parentheses. So I can take out a positive 3b, but pay attention because this might help you later. I obviously want the first one to be positive, the second one to be negative, which would help me to take out a negative 3. Good. So take out a negative 3b, and I would just get a, I did it again, didn't I? This should not be squared. A minus 2. Yeah. Now what's inside the parentheses is the same. Third times term. And I would group together what's left. What happens if there's 3 terms? We're just going to start with the first one today, and then we're going to stop. So probably the most common form of factoring, or not the first one, we're going to go first and second. Probably one, I would say first, most common is probably, or what you remember most is probably that second one. The first one is if there's 3 terms, and the first and the last are perfect squares. So we already said there's one where there's 2 terms, perfect squares. That's the difference of 2 squares. This one is if there's 3 terms, and the first and the last are perfect squares. Okay? If that's the case, and the middle term, so not just that, but also that the middle term is twice the product of the first and last, then it is a perfect square trinomial. That's what these are called. And again, think about those words. Perfect square means there's perfect squares involved. Trinomial means what? What's tri? 3. So there's 3 terms. So if we look at the example that's there in purple, Is the first term a perfect square? Yes. Is the last term a perfect square? So that information alone is not enough, okay? Because you can have ones that are like that and the term in the middle is not the double the product, which I'll show you how to get those tomorrow. But if those are both true and the middle term is twice the product of the square roots of those other two. So if I take this and I square root 4x squared, I get what? 2x. If I take this and I square root 25, I get what? 5. Find the product there, it's 10x. Double it, it's 20x. Ignore the sign because we're going to worry about the sign in a minute. If this term equals this term, then it is a perfect square trinomial. So if when you square root the first and you square root the last and you multiply those together and then double it, you get that middle term, then it's a perfect square trinomial. So there's a little bit of work to determine if it is, but then once you know that it is, the rest is easy. I'm going to square root the first term, which we've already done. That would be 2x. Square root the last term, which we've already done. It would be 5. Take the sign from the middle term. So that's when that sign comes in handy. The sign goes in the middle. I put them in parentheses, and I square it. And that's the factored form. So again, if I had expanded that out and foiled it, I should have gotten my question. So those are perfect square trinomials. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. Questions on that one? So if this had been a plus sign in here, the only difference would be this. Everything else would be the same. Okay, and then I'm going to do B, and then we'll stop and come back to C tomorrow. So B says we're under that there's 3 terms, so there's 3 terms. It's not a perfect square trinomial. The number at the front has a 1 in front of it, or the term at the front, sorry. So something like an x squared, or an a squared, or a y squared, the variables can change, but there is no number here. Then you're going to find the factors of the last term that sum to the middle number. So again, this is probably the one that you guys remember the most. So I would look at the factors of 28, and I'm looking for the factors of 28 that add up to a negative 11. Good. Negative 4, negative 7. They both have to be negative because I need a positive product. And this is negative. So I would do x minus 4 and x minus 7. This is the stuff you remember the most, right? Am I right? Yeah. Same process for the next one. There's nothing in front of that first term. It is a perfect square, but 32 is not a perfect square, right? So I don't even have to test it for the perfect square trinomial. But I'm looking for the factors of negative 32 that sum to negative 4. So the negative on the 32 tells you what 2 kinds of numbers are you looking for? Good. One's got to be positive, one's got to be negative, right? The only way for a product to be negative is if one's different. Yes? You with me on that? So what 2 numbers? Good. Negative 8, positive 4. So I'd get x minus 8 and x plus 4. Yep.
Is there an order they have to do?
No. As long as the negatives with the 8 and the positives with the 4, those 2 can be switched. The order does not matter. Questions on anything we've covered today? So we've covered all, in my opinion, except for the worst one, which we'll save for tomorrow. Okay, good. All right.